constant term c is negative 12. So we have 0 squared.
Fat Math, the right path to develop the fat brain that you've got. Hello everyone and welcome to Fat Math TV.
In this video, you will identify the nature of the roots of a quadratic equation without actually finding the roots. So roots, the roots of a quadratic equation are the solutions to the equation. So for example, we have x squared plus 8x plus 16 equals 0. What are the roots of this equation? So you can solve this by completing the square or by quadratic formula or by factoring. If you will do factoring, the factors are x plus 4 and x plus 4. So you will have x plus 4 equals 0 or x plus 4 equals 0. So x is negative 4 or x is negative 4. So we have two roots that are both negative 4. So if you will identify its nature, you can say that these two numbers are real numbers, and they are equal. They are the same. So some equations, some quadratic equations, have roots that are real and equal. How about this example? X squared minus 8x minus 33 equals 0. So if you will do factoring there, you will have x plus 3 and x minus 11. And then, if you will equate each factor to 0, you will get x equals negative 3 and x equals positive 11. So still, the roots are real numbers, but they are not equal. Particularly, these numbers are rational numbers. Real, rational, unequal. Because all rational numbers are also real. So if you have this, you can the nature of the roots will be rational, but they are not equal. How about this one? X squared minus 4x plus 1 equals 0. You can use the quadratic formula or completing the square, but because that's difficult to factor. So the roots are 2 minus square root of 3 and 2 plus square root of 3. As what you can see, it's still real, but they are irrational numbers. So for this one, we have irrational unequal. So they are irrational numbers, but they are unequal. Still, they are real numbers. So these three these equations have real roots. For the number 1, we have real and equal, because sometimes here we can also have an irrational, but they are also equal. So we have real, equal, we have rational, unequal, and for the third one, irrational, unequal. And then for the last one, x squared minus 6x plus 10 equals 0. If you will use quadratic formula or completing the square, you will get the roots 3 minus I and 3 plus I. So there are no real roots for this equation because the roots are complex numbers. It has imaginary part. Okay, so you have to remember these four. So the roots of a quadratic equation can be real and equal, rational and unequal, irrational and unequal, or there are no real roots. If you can remember the quadratic formula, we have x equals negative b plus or minus square root of b squared minus 4ac over 2a. Actually, this part of the equation here, or of the formula, the b squared minus 4ac, is called the discriminant. So the discriminant will tell us the nature of roots of the quadratic equation. For example, if you have here b squared minus 4ac, which is 0, so the square root of 0 is 0, and then you will have plus or minus 0, you will have equal roots. So we are going to have the same answer. So if the discriminant, or if that number or expression under the square root symbol is 0, then the roots are real and equal. And if it's positive or a perfect square, for example, the b squared minus 4ac is positive and it's a perfect square, then you can extract the square root, which is going to be a rational number. And then you will have negative b plus or minus that rational number over 2a is still a rational number. So in this case, the nature of roots, if you have b squared minus 4ac or the discriminant, which is positive and a perfect square, then the roots are rational and unequal. But if that discriminant or the expression under the square root sign is positive but not a perfect square, then you will have irrational unequal roots. So when you say perfect square, these are numbers like 1, 4, 9, 16, 25, 36, and so on. So those are the square numbers. But if they're not a perfect square, like for example 2, 3, 5, 6, 7, 8, 10, and so on, then you're going to have irrational unequal roots. And then if under the square root symbol is a negative number, of course you will have no real roots because the roots will be imaginary numbers. So you have to remember this. If the discriminant is 0, real, and equal. If the discriminant is positive and a perfect square, then rational and equal. If the discriminant is positive but not a perfect square, it's irrational and equal. And if the discriminant is negative, there are no real roots. So actually, this lesson will tell you or will teach you will give you the nature of the roots of the quadratic equation without actually finding the roots of the quadratic equation. Let's go back to our examples. So a while ago, we were able to identify the roots, but what if we will just go to the discriminant? Will we still have the same answer? So for the discriminant, b squared minus 4ac, b is 8, a is 1, c is 16, so b squared minus 4ac is going to be 8 squared minus 4ac. 8 squared minus 64, that is 0. So if the discriminant is 0, real and equal roots, which is also correct, because if we have here negative 4 and negative 4, they are real and equal. For the second one, the discriminant is b squared. B is negative 8 squared minus 4. A is positive 1 here. And c is negative 33. So times negative 33. So we have here positive 64 plus 4 times 33. That will give you 196. And 196 is positive and a perfect square. That is the square of 14. 14 times 14 is 196. So we have, if we have a positive and a perfect square, we have rational unequal, which is indeed correct. Negative 3 and 11 are not equal and they are rational numbers. And then for the third one, let's get the discriminant. Our b is negative 4. So negative 4 squared minus 4ac. A is 1, C is 1. So negative 4 squared is 16 minus 4, that is 12. And 12 is a positive number but not a perfect square. Therefore, the nature of roots, they are irrational and unequal. And lastly, for this one, the discriminant is b squared. So negative 6 squared minus 4 times 1 times 10. So that is 36 minus 40. That's negative 4. So if it's a negative number, there are no real roots. Okay, let us have more examples. Let us have these four equations. X squared plus 2x plus 17 equals 0. 2x squared minus 7x plus 3 equals 0. 4x squared plus 20x plus 25 equals 0. And x squared minus 6x plus 6 equals 0. This time, we will not identify the exact value of the roots. We will just identify the discriminant and give the nature of the roots of these quadratic equations. So if you think you already know how to solve this or know how to identify b squared minus 4ac, then you can pause the video and check if your answer is correct. Okay, let's check. For number 1, for the first example, a is 1, b is 2, and c is 17. So b squared minus 4ac is going to be 2 squared minus 4. A is 1 here, and c is 17. So 2 squared is 4. 4 times 1 times 17 is 68. 4 minus 68 is negative 64. Since this is a negative number, the roots are imaginary. There are no real roots. Number 2, we have here a is 2, b is negative 7, and c is 3. So b squared minus 4ac. Negative 7 squared is 49. Negative 4 times 2 times 3 is negative 24. 49 minus 24 is 25. And 25 is a positive number and a perfect square. Therefore, the nature of the roots they are rational and unequal. So the roots are rational and unequal. For number 3, a is 4, b is 20, c is 25. So b squared, that's 20 squared minus 4. A is 4, c is 25. So 20 squared is 400. Negative 4 times 25 is also 400. So 400 minus 400 is 0. So if the discriminant is 0, we have real and equal roots. Number 4, a is positive 1, b is negative 6, and c is positive 6. So b squared minus 4ac is equal to negative 6 squared minus 4 times 1 times 6. Negative 6 squared is 36. Negative 4 times 1 times 6 is negative 24. 36 minus 24 is 12. 12 is a positive number, but not a perfect square. Therefore, the roots are irrational and unequal. Let us have a second set of examples. We have 9x squared minus 6x plus 1 equals 0. X squared minus 12 equals 0. X squared minus 4x plus 8 equals 0. X squared plus 2x minus 15 equals 0. So for the first one, a is 9, b is negative 6, and c is positive 1. So we have b squared minus 4ac is negative 6 squared minus 4 times 9 times 1. Negative 6 squared is 36. 4 times 9 is also 36. 36 minus 36 is 0. So if the discriminant is 0, we have real and equal roots. And then for this one, a is positive 1. B, we don't have a linear term. So b is 0. And the constant term c is negative 12. So we have 0 squared because b is 0. Minus 4ac. 4 times 1 times negative 12. That's going to be 0 plus 48. So 0 plus 48 equals 48. And 48 is a positive number but not a perfect square. Therefore, the roots are irrational and unequal. Next number, a is 1, b is negative 4, c is positive 8. So we have b squared, that's negative 4 squared minus 4 times 1 times 8. Negative 4 squared is 16 minus 32. That is negative 16. So negative number, no real roots. Negative discriminant gives us no real roots. And then for the fourth one, x or a is 1, b is 2, c is negative 15. We have b squared minus 4ac, that's 2 squared minus 4 times 1 times negative 15. That's 4 plus 60, which is 64. And 64 is a positive number and a perfect square because that is 8 times 8. So the roots are rational and unequal. Okay, try these items. We have 6 here. For number 1, we have x squared minus 2x minus 26 equals 0. Number 2, 2x squared plus 3x minus 9 equals 0. Number 3, x squared minus 10x plus 29 equals 0. Number 4, 4x squared plus 28x plus 49 equals 0. Number 5, x squared plus 4x plus 2 equals 0. And number 6, 6x squared minus 13x plus 6 equals 0. For number 1, a is 1, b is negative 2, c is negative 26. For number 2, a is 2, b is 3, c is negative 9. Number 3, a is 1, b is negative 10, c is positive 29. Number 4, a is 4, b is 28, c is 49. Number 5, a is 1, b is 4, c is 2. And number 6, a is 6, b is negative 13, and c is positive 6. So you solve for the discriminant and identify the nature of the roots. So zero discriminant will give you real and equal roots. Positive determinant and a perfect square will give you rational and unequal roots. And then if you have a positive discriminant but not a perfect square, you will have irrational unequal roots. And if the discriminant is negative, there are no real roots. Pause the video if you need more time. Number 1, the discriminant is 108. That's positive but not a perfect square. So the nature of roots, irrational, unequal. Number 2, the discriminant is 81. That is positive and is a perfect square. 81 is 9 times 9. Therefore, the roots are rational and unequal. Number 3, discriminant is negative 16. That's a negative number, so there are no real roots. Number 4, discriminant is 0. So real and equal roots. Number 5, discriminant is 8. That is a positive number but not a perfect square, so irrational, unequal. And number 6, lastly, number 6, we have discriminant is 25. That is a positive number and a perfect square, so we have rational and unequal roots. That's it for the nature of roots of a quadratic equation. See you in the next video. Thank you for watching. Comment, like, and subscribe. Bye!